SwayamPrabha. Digital India. Educated India.
In this lecture, we'll be discussing about LCA in more depth, life cycle assessment. But before we discuss about LCA, we need to understand some basic concept. One is this design for cradle to cradle. So even before that, we need to understand what is meant by cradle to grave. So in this image which you see here, cradle, as you know, is when a child is born, we keep them in cradle. Grave is when somebody dies, we keep it in grave. Similarly, for material cycle also, the material is going to go through from the extraction to manufacturing, to construction, to usage, and then disposal. So, do you think cradle to grave is a good concept, is a good idea or not? So, cradle to grave is going to increase the amount of waste. So, we need to do something on this. That's why cradle to cradle is going to come. Cradle to cradle is where we are going to take the material and complete the cycle. So while disposal or before even disposal, we are going to take care of, so from the extraction, production, distribution, usage, we are going to either reuse, so it's going to go back to the usage, part of it, or part of it could be recycled material, which is going again to the manufacturing. Part of the materials can be recovery, that is, it is going as an ingredient from the raw materials. But unfortunately, there will be some part which is going to go for incineration, landfill. That if we can completely eliminate, then we can say yes, we have achieved cradle to cradle. So what is required for this? What is exactly required for this achievement? If we want to achieve this, we need to start thinking in a different way. So we need to think in a way which enables us to have cradle to cradle. That is life cycle thinking. You think about the entire life cycle of the product and see how we can achieve this cradle to cradle. So what is this life cycle thinking? It is essentially to sustainable consumption and production. It enables us to sustainable consumption and production. It is about going beyond the traditional focus on production sides, manufacturing. So the environment, social and economical. So we have already learned these three pillars of sustainability. And this we need to think about the entire life cycle. That's why in product design is so important that we think about the entire life cycle of the product, from the consumption, from the usage, and take care. Something else we need to think of, that products have materials and energy. So we should use recycled materials and we should use renewable energy as much as possible. So product life cycle assessment, that is LCA, where the Originally LCA is basically from cradle to grave. It's a quantitative system or quantitative tool, data density very much. Standardization ISO 14000 is related to the standard of LCA, where in ISO 14000 part of the ISO 1440 especially talks about LCA. It has already become global LCA. Of course, there are some eco-design strategies which are very important, like use of eco-design strategies. Some of the recommendations for this are reduce use of material content of the product. So how we can do that? Previously, if you see the engine of car is so heavy, it is not optimized. So later on, people optimize it, reduce it the weight, so the material content is reduced. If the material content is reduced, then what is going to happen? The car is lightweight, it is going to use less fuel, it is going to run faster. So the material content of the product, if it is reduced, then the material requirement for this manufacturing the material product is also going to reduce. Reduce energy content. So how to reduce? There are again, if you see any car, previously it is not that efficient. A lot of fuel is to burn. Now car with the same 1 liter of petrol, it can last much longer. You can drive, or one can drive, or you can cover a longer distance. So this is what it is about: energy content and energy usage. Next thing is something important is try to design ideal product where no product. So ideally, if you can eliminate the requirement of product itself, still if you satisfy the need, then fine, you can go ahead with this one. Then increase recycled material of the product percentage. That's going to help. Design products for life. And this is again important. Previously, two-wheeler used to learn, our uncles and forefathers, they used to, they used to have same two-wheeler for 15-20 years. Now new two-wheeler we are purchasing after 5 years. There's so many issues are there. So these products are not designed for life. If a product is not performing, then people are going to get frustrated and change the product, which should not happen. But having said that, it is not just about designer's problem, it is also about the problem of the technology. This is a mobile phone. If you see that mobile phone, there are certain people who are changing the mode of mobile phone very fast, because they wanted to get some more new things, new mobile, new stuff, which is not required. However, there are sometimes we are forced to change. Take for example, when the service of 4G came, 3G mobile phones are not that useful. There are some issues that are coming. So people have to buy 4G mobile phone. So that is called technical obsolescence. And second one is about product obsolescence. So sometime we change the product. So if you have a product which is having a longer lifetime and we are ready to use, then those products will be better, right? Next is eliminate unnecessary and unused and unnecessary product features. There are now many products are there which is having many features, because people tend to buy a product which is having more and more features. Do we really need that? So sometimes we don't need products which are having so many features we don't need. So let us buy the products which are satisfying our requirement. So the designer is our responsibility is don't just try to sell a product just because it added more features. Better that we focus on requirements. Design for fast economic disassembly and major components prior to recycling. So we need to, another design strategy that when a design product is there, if you want to recycle, reuse, we have to dismantle because product is made with multiple materials. So if it's difficult to dismantle, it's difficult to recycle. Make it such a way, it is easy to do that. Some other things are design products compliant to standards and directives. RoHS, V, REACH. So restriction is hazardous substances, V and REACH. So there are some these products which we are going to design. It must be standard compliant. Otherwise, we cannot sell this. So these products, take for example any product, any electronic products we make, computer, laptop, mobile phone, charger, all these things has electronic circuit. And if you want to sell this product in international market, even in national market, it has to basically adhere to some of the standard which are there already in the market. RoHS, restriction of hazardous substances, is one of the standards. Waste electrical and electronic equipment, that is another standard. REACH is another standard for chemicals. So these standards need to be maintained very rigorously. Design products that could be used, reused, recycled and remanufactured, which means that when you are designing the product, we are not thinking about just usage, how the people are going to get satisfied. No, that is minimum thing. But apart from that, how we can bring back this material back in the, make it a closed loop cycle. How can you reuse? How can you remanufacture? How can you recycle? Then LCA, we have to conduct life cycle assessment and where the opportunities to reduction that we can do and improve the ecological performance. Take back is another thing. Company should be able to understand that products are often used for a service, right? Like previously, the Boeing and Airbus, they used to buy engines for their flights, for the airplane. However, nowadays, many times they basically rent the engines. So Pat and Whitney, other GE, other companies, they are going to give engine as a service, and the service maintenance and all these costs are being borne by the company. Same as often we rent a car, right? For 5, 6 days, if you want to go somewhere, you rent a car. So we don't need to always buy. We don't need to always buy things to use. Sometimes we can rent it, right? So similarly, in the product, if somebody wanted to use it, if I design a product so that it can be taken back by a company, then you will design the product very differently. Then lease the product or sell the service. That's why I told long-term performance and end-of-life collection, that is to be done in a better way. So when you have the life cycle assessment, life cycle inventory as analysis, if you take a black box, if you take a product, what are the inputs or which are things which are going while making the product? It is generally it is product material and energy, and what is released to the atmosphere. Sometimes it is waste, sometimes it's product, sometimes it's byproduct and other things. So this is basic analysis we should do, input and output analysis. So now we coming to sustainability and eco-design. How will you do sustainable product design? Take a product or a concept, select whichever you like for analysis, then analyze it, use life cycle assessment, find out the amount of material and usage during the entire life cycle and each and every phases, redesign it wherever you can see that a lot of possibilities of reduction, analyze it again with the LCA and then compare and do the improvement. So this is a good way of reducing the emissions, reducing the waste, reducing pollution. Emission means not always the carbon dioxide emission or the equivalent, the waste we are creating, that also is basically waste. That also is something which is undesirable. Now we are going to go a little bit of LCA. So life cycle assessment is a method in which energy and raw material consumption and different types of emissions related to specific product are being measured, analyzed and summed over the entire life cycle of the product. It is from cradle to grave concept, and it started like kind of 1970s. Emissions and raw materials were added later, and LCA is considered as a comprehensive analysis or assessment of life cycle assessment. So now in this slide you see, according to ISO 1440 standard, this is the framework for life cycle assessment framework. You start with goal and scope definition, where you actually try to figure it out what exactly the scope goal of this issue is, what is the goal of the problem, and what exactly the problem we are going to address. Second is inventory analysis. Inventory analysis is where you assess the entire life cycle of the product, starting from the extraction of raw materials to manufacturing to design, and is going on. So is what exactly is going on in the product and what exactly is coming out of the product. Then we go to impact assessment. Impact assessment is, for this you can convert it to CO2 emission, CO2 equivalent and various other assessment, and you can use assessment criteria like assessment methodologies also. And this can be done either using manual way, or you can use some kind of tools for this. The interpretation, which is going to go all the way around from the goal definition, inventory analysis and impact assessment. This impact interpretation is basically telling us how we are going to interpret this analysis. What is your interpretation in terms of the expertise which somebody is having in LCA? So where are the issues in this analysis, in the results? And direct applications of this is in product development, strategic planning, then product policy making, marketing and others. There are a wide range of applications of LCA which are there. A little bit of description of this is goal definition and scope. Its importance established beforehand, and the model is served. And when one wishes to study where the system boundaries. So take for example, we are going to identify the pen. So if you want to do LCA pen, are you talking about only pen, or you are talking about the machine which is required for the manufacturing of this pen, or something else? So what are the system boundaries? So what are the basic evaluation technique? What are the temporal boundaries? What are the spatial boundaries, geographic boundaries? Next is goal and scope. Here, what is the functional unit? System boundaries, assumptions, limitations, allocation methods. So allocation method is something like, if you have same machine, same manufacturing base, same manufacturing room is being used to manufacture 2 or 3 different components. Same machines are used to manufacture them. Now, the emission caused by each of these machine had to be attributed or divided into such a way that it have some amount of emission added to the one product, and similarly of others. Impact category chosen. Are you talking about CO2 emission only? Are you talking about health issues? Are you talking about... So there are so many ways in which you can measure the impact. Which one are you going to take? So there is no standardized method of this, but there are some methodologies which can be used for this. Inventory analysis, it is the input-output analysis which determined in terms of material and energy. So that's what I'm told, that what are the things that are going inside and outside. Start making a process tree. Classify them. Find out relationships. Relevant data you analyze, take it. Then establish the connection between the material and energy balances. Next is LCA, where life cycle inventory analysis, that is LCI, life cycle inventory analysis involving the inventory flow from and to the nature. What is going from the nature? What kind of material? At what stage? What energy? And then what is going to the nature in each and every life cycle, each and every phase of the product. It could be water, it could be energy, raw materials released from the air, by the air to the air, land, water, and the flow model you make, flow chart, and put the values also, that is very important. Amount. So this is an example of simplified LCA, one of the examples of LCA done on coffee machine. Coffee machine, if you see here, see that one coffee machine is there where you can put water, filter paper, water, and there is a bucket is also there, that jug is there, and the machine is going to heat the water, and then add, there will be another place where you can put coffee powder, and it's going to heat the water, add the coffee and give it in the jug, and then you can take the coffee. So this block diagram is going to showing how this, what kind of components are coffee bean, paper, polystyrene, aluminum material is used, and then is going to go in assembly and packaging, usage, after usage. So this is the entire in short life cycle of the product, coffee making, coffee machine. Then you put materials in terms of how much material is getting. 7.5 kg of paper is being added, 1 kg of polystyrene, 1 kg of aluminum, and all these things, each of this, and also energy. This is very short version where more detail is of course required, and then you find out the electricity also how much is required. Then you put life cycle assessment. It contains impact categories, category indications, categories, models, stages, and impact measurements, LCA flow. Then impact assessment, interpretation, final life cycle stage analysis is done, ordinal goal definition is done, then it is having high impact, larger impact, and how these sources are required. This is all this interpretation we are doing in this step. Then LCA. Interpretation is systematic technique to identify, quality, check, and evaluate information. Here we are using ISO 1448/2006 version, new one also. It is with respect of LCI, LCA, we evaluate, study and considering completeness, sensitivity, we can use consistency, and then conclusion, limitations, and recommendation. Now here one thing one going to ask that, okay, emissions are taking place, so how this is related to human health? So this slide is going to showing that emissions, it is adding to the atmosphere. Concentration, like how much emission, at what rate that we take, and then use sensor data. Sensor data means one location, how many people are there, and the year data, and then we have this kind of some kind of research has been done to map with respect to health effect. Now typical example which you see here, paper bag and coffee bag, paper bag and plastic bag. Nowadays if you see and go to the market, in the name of environmental sustainability, you will get a paper bag, right? And you feel that that is good. Plastic bags are many times eliminated. But these are the right thing to do or not? Think. If you want to use paper bag single time or plastic bag single time, then paper bags are better. However, if you want to use multiple times, then of course plastic bags are good, right? So this is analysis where it is having various effects on winter smog, pesticides, other things, and how they are performing with respect to each other. This analysis is done. You can do LCA and find out. Even there are different kinds of paper bags. There are different kinds of plastic bags. It's not that easy to just tell this is better than that is not better. So LCA is going to help us in understanding that. So summary of LCA, goal and scope definition, what is the purpose, inventory analysis, functions, boundaries, limitations, interpretations, assessment first and then interpretations on the environment. All these things are summary of LCA. See, LCA is a really difficult task. It requires a lot of data, a lot of analysis. So for smaller product, you can do it manually. We have done many times in research. However, for bigger products, we need help. So there are some software and very good software available with data initially for US data, European data, and now it is a lot of Indian data is also available. So this software is going to help in, especially in the impact assessment, from the emission to impact assessment, finding out the values. Gabi is very well known. SwayamPrabha is another well known tool. Then ID MAT is another one. LCA, TEAM, EcoScan, IVAM, LCA data. These are things which can be used. So first two are very important and very widely used. These any of the software can be used for this. Now, design thinking. Design thinking can be extensively used in sustainability to achieve sustainability, and here we are going to get a little bit of understanding of this. The design thinking is an innovative and creative approach that we already know to solve most of the complex problem, and sustainability, achieving sustainability, and this is what is also regarded as a very complex problem. It's a multidimensional problem. So design thinking aims to develop creative and user-related ideas to find out resolutions and positive impact on the future. It is referred to as solution-focused thinking. So it means that asking the right questions, knowing about sustainability, sustainability cost, sustainable strategies, and involving the stakeholders. So all these things we have to understand, and then we can use design thinking. So as human-centric design, it is important to adapt this approach, fine-tune, and customer should be more environmental friendly decisions they should be making, solving sustainable issues, and some other questions we should be thinking. Does this product contribute to the future human need? Not just about making money by the company. Is it useful to the customers? So is the goal and purpose for this, and does it make people happy in the environment? And how sustainability with respect to this particular design can be measured? And can I help people to be more sustainable? So what is design thinking for sustainability? It is a current environmental, economical environment and continuously evolving and social economic in propelling the marketplace. Organization being motivated and has challenges to shift from one to top down and bottom up strategies, and the governance leaders, that is sustainability, that is CSR and environmental social responsibility, that we have to need to focus. So it helps a lot and involve the people, especially designers, to think sustainability using design thinking approach. Thank you.